Hirschiman. So, yep. So we were chosen. That's why I'm wearing. She dressed me today. So it's funny when I came in this morning, someone was like, "You look very festive." Anyway, so very fun, very fun. So, you guys good on homework? Didn't have any questions? All right. Last night, all of our problems that we did were exponential. They were either exponential growths or exponential decays, and then we shifted them left, right, up, down, etc. Remember, if you go left and right, you're up here with the x. If you go down and up, it's out to the back. Okay? Any questions at all on last night's homework? All right. So once again, let's take a look at our notes for today. These are the exact same notes we started off with yesterday. I'm trying to drill this into your head. What are some of the key things you guys can tell me about f of x equals 4 to the x? It's an exponential growth. Okay, it has an asymptote at what? Asymptote.
0.
Okay, at the x-axis, right? Then it has a y-intercept at what? 1. And then since it's a growth, it goes what? Up and to the right. Correct. That's your exponential growth. The logarithm is the inverse of this. So now I have an asymptote where? At the what? Y-axis. And then instead of having the point 0, 1, I have the point what? 1, 0. And then this one approaches the asymptote towards negative infinity. So this one's going to do the same thing. It's going to approach the asymptote towards negative infinity. Okay, towards negative infinity. What if my original problem was f of x equals log base 1/4 of x? How would that change my problem? Well, what would the inverse of that be? It would be what? 1/4 to the x. What kind of graph would that be? Exponential what? Decay. Still have an asymptote here. Still crosses at 1, but it goes this way. So now what can you tell me about my logarithm? If my base, so now we're looking at this number, is less than 1. Now I still have my asymptote at the y-axis. I still cross at 1, 0, but now remember you're approaching your asymptote in the positive direction. So approach the asymptote in the positive direction. And there's your graph. Okay, do you guys remember those graphs? We've kind of talked about them a whole bunch. Looking at the logarithm graphs, the red ones, what affects my asymptote? Shifting which way? Left and right. If I go left or right, my asymptote is going to move with it left or right. If I go up or down, does my asymptote move? If I reflect over x or reflect over y, does my asymptote move? No, it's just if I go left or right. So that's where you have to watch your asymptote transformation. All right. So looking at our chart, we have this chart. Once again, if I start with this function, f of x equals log of x. By the way, what's my base? 10. So this would be the inverse of a growth function. The inverse of a growth function. Good. All right. Well, if that's my original graph, if it's in parentheses, there was a problem that we did the other day, and someone asked when we were writing the inverse if it mattered if my x minus whatever was in parentheses, and I said yes. Because if it's in parentheses, that tells me it's going which way? Left and right. So if it's minus, it goes right. If it's plus, it goes left. Whereas if it's not, I hate when this thing jumps like that. Okay, if it's not in parentheses, that shows up and down. So parentheses are extremely important. If it's in parentheses, left or right. Not parentheses, that's up or down. Up 3, down 1. Okay? The next one, if we reflect over y, you make x negative. If you reflect over x, you make y negative, and y is the whole equation. So you put the negative out front. These rules are not changing. Now, if I want to do a horizontal shrink by 1/4. So again, horizontal shrink by 1/4, your x is going to become 4x. So everywhere we see an x, we make it 4x. If you do a horizontal stretch by 3, now everywhere you see an x, you flip it, it becomes 1/3 x. Verticals are still the way they've always been. You just put a 5 out front. That's a vertical stretch by 5. You put a 2/3 out front. That's a vertical shrink by 2/3. Questions on our rules? All right, so let's look at our first one. Describe the transformations, then graph the function. Describe the transformation, then graph the function. So we have f of x equals log of x. So here's my original function. There are 2 transformations that have happened. What are they? What are they, Drew? What's one?
Horizontal stretch by 2.
He says a horizontal stretch by 2. Do you guys agree with that? Good. Horizontal stretch by 2. Why is that? Because he multiplied x by 1/2. So since it's by x, it's horizontal, reciprocated, it's by 2, so it'd be a stretch. What else is with that? Okay, we have a negative with the x, so that would be a what? Reflect over y. Very good. Reflect about across over the y-axis. Perfect. So there's my transformations. Now let's think about one other piece of information. What is the base? 10. So since the base is 10, bigger than 1, your parent function looks like this. Okay? It's the reflection over the line y equals x of exponential growth. So I always start, I'm going to take, and I'm going to real lightly draw my parent function. So it would be out 1, and then it would go like this. So this is f of x. Okay, there's my parent function. Now, it's reflected about y. I'm going to do that first. If I reflect it over y, now this point goes over here, and it now goes like this. So this is reflect y only. And now if I do a horizontal stretch, let's talk about this once. If I do a horizontal stretch, what's going to happen to this? It's actually going to get what? Flatter. Okay, so it's going to get even flatter. It's still going to go through that point. Actually, it's not going to go through that point. Let's talk about that once. What does this point become? If I have the point here, and that point was originally at -1, 0. If I do a horizontal stretch by 2, what are you going to multiply x by? So where's that new point going to go? Right there. So it gets stretched. And here's your new graph. These can get a little tricky. I don't love the horizontal stretches when they change the point. All right, let's look at another one. Okay, let's think about what that graph looks like. Okay, remember, since my base is 1/2, it's the reflection about Remember, it was like this. So which way is it going to go? Okay, this is the exponential. This would be 1/2 to the x. So how would you guys draw the log function? Well, it goes out towards your asymptote, towards positive infinity. So it's going to go through here. It's going to come here and go that way. So this is f of x. Okay. What transformations are happening to g of x? What transformations are happening to g of x? Josh.
Left 4.
Left 4. What else? Vertical stretch by what? 2. Are you guys good there? Okay, so first let's take this and let's go left 4. So my asymptote was at the y-axis. It's going to now go left what? 4. My point was at 1. It's going to go left 1, 2, 3, 4. And now when I do a vertical stretch, what's going to happen? It's going to get stretched out a little bit. Does that point move? Okay, vertical. Which coordinate am I affecting here? The what? Y. This point is at -3, 0. If you multiply that by 2, does that get changed at all? No. So that point did not move. I'm just going to take, I don't know why I used light color. I'm just going to take and I'm going to stretch that out a little bit. So again, what do you have to show me? What am I going to check? Just like you should have checked on your homework last night. Asymptote. Move your asymptote. This key point, move it. Those 2 things. And then the general shape. What do you guys think about those 2? Are we good there? All righty. Now we're going to write equations. Let G be a reflection over X followed by right 4. Here's my original graph. So the first thing they want you to do is reflect X. All right. What do you guys do when you reflect X? Okay. What do you do when you reflect X? You make Y negative. Y is the whole thing. So we just put a negative in front of what? In front of the 2 to the X. Put a negative out front. That is a reflect over the X axis because you made Y negative. Y is the whole thing. Now we want to go right 4. What do you guys do when you go right 4? Where? Up with the X minus 4. Now, somebody might say, I put my minus 4, X minus 4 in parentheses. You can have it in parentheses. You don't have to because that is indicating it's up with the X. Questions on that one? Okay. We're going to first do a horizontal stretch by 3. Horizontal stretch by 3. And here's my original problem. So what do you guys do when you do a horizontal stretch by 3? We're going to, X is going to become what? 1/3 X. So I have G of X equals E, and then I have negative, and then in place of X, I put what? Oh my goodness. All right. Can I simplify that to just -1/3 X? Yeah. So this is just E to the -1/3 X. And now we're going to go up to, what do you guys do when you go up to?
+2.
Yeah, +2 where? down here. That's +2, up 2. Questions on that one? Are these pretty easy so far?
Yeah.
Okay, good. I'm glad we're going to have some time to work on our homework in a minute. Let's look at this one. Now we want to go up to start. And here's my original. Okay, so how do I go? Up to log base 1/3 of x. And then what do you do to go up to? Add 2. 2 on the outside. And now we want to do a vertical stretch by 2. Vertical stretch by 2. All right, this is where it gets just a smidge. You got to be careful. So what are you going to do when you do a vertical stretch by 2? Multiply the whole equation by what? 2. Now, we have 2 parts here. So I'm going to put this to the front, just like when you did it to the square root. You cannot put it with the inside of the log. Okay, and then this 2 is separate, so I can give it there. God bless you. Just wanted to outdo the people in the hallway. And when you do, what do you guys get? We would have 2 log base 1/2 of x plus what? 4. Good. I don't think that was too hard. Oh, it is 1/3. Okay. Are you guys good on that? All right, last one. Reflect over the y-axis. Okay, so what do we do when we reflect over the y-axis? And then where's my original? Here's my original. So what do you guys do when you reflect over y? Make the x negative. So it's just going to become log of. Now, I am going to put that in parentheses because it's the log of negative x. Now, here's the hard part of this one. What are we going to do next? We're going to go left 4. What do you guys do when you go left 4? Add 4 to x. But do you remember, anytime you go in with x, it's just x. So I'm going to put that in parentheses. I have log of negative x plus 4. You always, when you go left or right, put just the x, replace that with parentheses, x plus 4. Because now what am I going to do with this negative? And when you distribute it, you get the log of what? Negative x. And yes, that has to be in parentheses because it shows that it's going left or right, not down. All right, what do you guys think? All right, homework. Happy Friday.
Is there any graphing?
Yes, there is graphing.